Hello students, welcome to the course Dynamics of Machinery. In this lecture, we will study the concept of inertia force, DLMS principle, force analysis of reciprocating engines. We also solve numerical problems and understand the dynamically equivalent system of connecting rod. Before studying forces in machines, let me understand the inertia. When we are moving in a bus, suddenly brakes, then those are sitting in the bus also moving forward. This concept is due to because of the inertia. This happens because every object tries to resist any change in its state of motion. This property is called inertia. Therefore, let me define inertia as the property by which it opposes any change in state of rest or uniform motion in a straight line. Greater the mass of an object, greater will be its inertia. This is why pushing a bicycle is easy, whereas pushing a truck requires much more force. In machine dynamics, inertia plays extremely important roles because moving machine parts continuously accelerate and decelerate. Inertia is proportionate with respect to the mass. That's why I am telling you that moving a bicycle is easier than moving a truck. So the mass of the truck is more than the bicycle. So the inertia effect is going to be much more than the bicycle in the truck. We are often use the terms mass and weight interchangeably, but they are different. Mass is the quantity of matter contained in a body. It remains constant everywhere and measured in terms of kg. Whereas weight is the gravitational force which is going to be acting on the mass. So weight equal to mass into mg. The g is the acceleration due to gravity. For example, as an astronaut has the same mass on Earth and Moon, but his weight changes because the value of gravitational force is going to be changes. So in machine dynamics, we usually deal with mass because inertia depends directly upon the mass. So we can see the football mass is different from the heavier stone. Newton's first law of motion is going to be states that every body continue in its state of rest or uniform motion in a straight line unless acted upon by external force. This law actually another way of describing the inertia. The body doesn't change in its state by itself. An external force is required to move the body. This principle forms the foundation of dynamics and helping us to understand the inertia forces which are generated in the machines. So you can see that the object will be at rest, continuously will be at rest, unless otherwise it is acted upon by external force, it is not moving. Similarly, when the object is in motion, it will be in motion unless or otherwise it is acted upon by some other force. In case of football, if you are kicking the football, it is continuously moving, but at one point it will stop. It is stopping due to because of the resisting force, due to because of friction in the air, and some cases it will be the friction due to be in the ground also. So the object will be in state of rest or motion unless otherwise it is acted upon by external force. Let me check your understanding. Imagine a place in the cosmos far from all gravitational and frictional influences. Suppose you visit that place and throw a rock. Whether the rock will gradually stop or continue in motion in the same direction at constant speed. If you are telling B, then that is the correct answer because there is no friction, so the rock will be in continuous motion in the same direction at constant speed. Similarly, a 2 kg object is moving horizontally with a speed of 4 meters per second. How much net force is required to keep the object moving at this speed and in this direction? That is, a object is moving horizontally with a speed of 4 meters per second. They are asking how much net force is required. The net force is not at all required because already it is the moving. So object will be in moving, unless otherwise if you want to stop, then only the additional force is required. So the net force required here is 0. You have to see the term net force. Already the force is there to put the body in motion. In machines, moving parts generate inertia forces. If these forces are not properly balanced, you see that this is a rotor. In the rotor, if the mass is equally distributed, then the inertia force also equally distributed. If the masses are not properly balanced, then the unbalanced force will create the unbalanced inertia, which will lead to vibration. This vibration will affect the shaft or bearing, noise, and if the continuous vibration will produce wear of the components and reduction in machine life. Therefore, we have to balance the unbalanced masses. So if we are having a 10 gram of unbalanced mass at this place, we have to keep the equivalent opposite same 10 gram of mass in the opposite direction. Then only this rotor will be in balance and it won't produce any vibration. Let us understand DLMS principle. Suppose you are pushing a trolley. When the trolley is going to be accelerates, you need to apply an additional force apart from overcoming the friction. Why? Because trolley possesses mass and hence develop inertia. Instead of considering the body to be accelerating, DLMS suggested introducing an imaginary force called inertia force acting opposite to the acceleration. This is just what we are doing in the previous slide. What we discussed is the inertia force. Same thing here, DLMS is discussing that it has the imaginary force because we can't able to see it, is it not? So it is inertia force which is definitely acting opposite to the acceleration. So if I want to move the mass or any trolley ship like that, so the inertia force will be acting opposite to this. So mathematically it is nothing but the applied force I want to move anything should to be equivalent opposite to the inertia force. This is the beauty of DLMS principles. It converts difficult dynamic problem into simpler equivalent static problem. In machine dynamics, almost all force analysis of reciprocating engines are based on this principle. So I once again conclude in this slide that DLMS principle state that the resultant force is going to be acting on a body together is nothing but it is the reversed effective inertia force. So that is both will be in equilibrium. Fi should be equilibrium. So whenever we are looking upon any machineries, it may be bicycle or crane or excavators or robots, we have to do some force analysis. So the dynamic force analysis is very important. In that case, if it is going to be for robots, what is the need of dynamic force analysis? Because here our main objective is to determine how much force is required to move each and every part of this robotic arm, so that I can able to move a mass which is going to be pick and place from a robot. So this is nothing but once again a force analysis. So I have to analyze the forces which is going to be acting on the each and every arm by calculating the weight which is going to be lifted by the robot. Similarly, nowadays most of the places we are talking about drones, even in war conditions. So for drone as going to be fly, so what we have to do means we have to use these forces analysis. Okay, how much force each propeller is going to be creating, and what is going to be the importance of each and every rotors, impellers, how to design the frames due to because of these forces. All those is due to because of your force analysis only. So it is once again a dynamic force analysis. This is another example. The next we are going to our classic example, slider crank mechanism. So observe the very basic mechanism, slider crank mechanism here. It is an IC engine. So the piston here, it is moving in a straight line where the crank is going to be rotated. The connecting rod which is connecting the piston, connecting rod is connecting the piston and the crank. So the connecting rod is having two kind of motion. One here it is reciprocating motion, the other end it is rotating motion. This combined motion effect will create different kind of forces. And also the connecting rod is in inclined position. So our objective is to identify these forces. What is the purpose of these forces? Since this is ICE engine, isn't it? So there are different kind of ICE engine. There are single stroke, there are two stroke engine, four stroke engine, okay, single cylinder engine. Previously I told it is okay, single cylinder engine, then four cylinder engines, then IC for truck engines, there are aeroplane engines. So what is this? How this power is coming from? Where? It is nothing but the power is coming from the fuel. Everyone knows. How this fuel power is converted as a torque, that we want to know. Torque which is rotating the crankshaft. So this is the main objective of this, our dynamic force analysis. So in our force analysis, we generally follow the steps, that is determining the gas force which is acting on the piston. So it is your FP. Then calculate the inertia force of the reciprocating parts. Then determine the piston effort. Then the fourth step is calculating the force transmitted to the connecting rod. Then determine the crank pin effort, that is your FT. Then determine the bearing load, turning moment, all those things. So what is this? Just I am telling these are the steps. It is nothing but very simple. We have to see how the force is going to be generated in the IC engine. So what are the forces generated? So the force actually here it is going to be, we are getting the fuel and it is ignited. So what is happened? The gas pressure is pushing the piston. So what is this gas? Whenever the gas pressure is pushing the piston, the inertia force will definitely acting opposite to this. So we have to calculate the net force. What is going to be acting? So the force acting on the piston is nothing but FL minus Fi. Initially we consider these two things. What is this FL? FL is nothing but the force due to because of the gas. Fi is nothing but the inertia force. Okay, so what is happening here? So there is a gas force which is acting, but that is going to be opposed by the inertia force. So the net force which is acting on the piston is Fp equal to Fl minus Fi. So at the same time there will be a frictional resistance acting opposite to that. Then due to because of it there is a normal reaction. Then the weight of the reciprocating parts. So this is the normal reaction due to because of moving piston, which is affecting the cylinder walls. So this force is acting on this. So this is the force Fn is the force which is acting on the cylinder walls. The weight of the reciprocating parts, definitely we have to consider it in the vertical engine. Then this force, the piston force, is going to be transferred along the connecting rod. We have to name this as the Fq. Then at this point, since the connecting rod is inclined to crank, we have to resolving it along the crank, that is going to be Fb. Perpendicular to the crank, it is Ft. So these forces are going to be very important forces because This Ft is the very important force which is rotating the crank, and it is eventually converted into torque. Torque equal to Ft into R. This Fb is nothing but which is the force which is directly hitting this crankshaft bearings. Very important, because if this force is high, then the bearing will get damaged. Let us observe the direction of forces. Gas pressure pushes the piston downwards. The inertia force is going to be opposing it. The connecting rod transmits the force to the crank. Finally, the crank is converting the force into rotating torque. This energy transmitted from the piston to the crankshaft.
The
In
connecting
practical
rod
engines,
and the piston in
the
the
connecting rod
single-cylinder
angle
engine,
continuously
the rotation
changing
of the
during the
crankshaft
rotation.
and the
As a result,
flywheel in black
the
needs to be
tangential and
defined.
radial
The
forces
rest of the
also keep
motion is
changing,
calculated
which
by
is
the rigid
acting,
body
that is the
solver.
Ft,
This means that
and
the complex kinematics
Fb,
are
what we
actually
have seen the
solved
last
based on the
slide, will
rotational speed of the
continuously
driven
change
component.
according
The
to the
motion
angle
of
of
the
the connecting
piston
rod.
and the connecting rod
Therefore, the
does not
torque
have to be
produced by the engine
predefined.
is not
It is a
constant
result of the
throughout the
simulation.
cycle. This fluctuation is the reason for using the flywheel. What is flywheel? Flywheel is the one which is storing the excess energy during the expansion stroke. So it will be connected outside the crankshaft. Then that will give the energy return back to the crankshaft to rotate in the remaining cycles. So with this, I am completing the introduction to inertia forces. So in the next video, we are going to see what are the forces acting the IC engine in detailed manner. So we are deriving the formula, and in the next one we will do the problems. Thank you.